On these first couple of examples, we want to give the domain, range, center, vertices, foci, and equations of the asymptotes for whatever hyperbolas we have. So let's look at problem A. On problem A, we have x squared over 25 minus y squared over 144 equals 1. Now, if this were a final exam or a test, you wouldn't be told that this was a hyperbola. You would have to know that this is a hyperbola based on the fact that you have a minus sign in between your x squared and your y squared. That would be your only dead giveaway that this is a hyperbola and not an ellipse. Now, because the x comes first, and this does matter when you're talking about a hyperbola only, because the x comes first, that means that you're going to be opening up left and right along the x-axis. That's what all this fancy term down here means, that we're going to open left and right along the x-axis. Now, because there's no numbers with the x squared and no numbers inside the y squared, that means your center is just going to be where it is normally, starting at 0, 0. Now, remember your A is always under your first piece here when you've got a hyperbola. So that means your A is 5. Remember, your A is always squared in these formulas, and your B is always squared. Your B in this one is going to be in the second one, which is, again, remember, the B is already squared. So that means your B is going to be 12. Now, how do you come up with the equation of the asymptote? Remember, it should be y equals plus or minus, think of it as rise over run. That's the way I think of it. Y's over x's, and again, we're going to use the radius. Well, the y's here were the b, which would be 12. So rise here is your b's, your y values, which would be 12, over your run, which would be your x values, which would be the a of 5. Now, normally you'd say, well, x times your x minus your value for your center, but that's just 0 here. The 0 coordinate, or the x coordinate for your center, which is 0, plus, again, is going to come from your y coordinate from the center, which is, again, 0. So the h and the k here, because our center is at 0, don't really matter. So because our center is at 0 and 0, this stuff won't matter. So our equation for our asymptotes is the 12 over 5x. Remember, there's two asymptotes, one with a positive slope and one with a negative slope. So I need to put a plus or minus out in front. Also, that helps us with the asymptotes. We've got the center. I also need vertices and foci. Well, vertices are going to be based on the fact that this graph opens left and right, and that the fact that the A is 5 for that major axis because the X comes first. So, because our A is 5, we'll go left and right, 5 on the X-axis, and those will be my vertices. So those two will be my vertices. Going from the center at 0, 0. Okay, so you went 5 to the left and 5 to the right. That created your vertices from the center, 0, 0. Okay, coming up with your foci. Remember, your foci for your hyperbola is actually a little bit different. It's c squared equals a squared plus b squared. Well, we said a was 5. So a squared would be 25. We said b is actually 12, which means 12 squared for the b squared to be 144. Well, that means c squared is going to be, well, I need to add these two up. 25 plus 144 will give me 169. then to actually find, this is c squared, to find actually c, I need to take the square root of both sides of the equation. Well, the square root of 169 is 13. So, if my c is 13, that tells me again, the major axis is x, so I'm moving left and right. I'm going to move left 13 and right 13 from the center, which was at 0, 0. So that means the foci are going to be at 13, 0 and negative 13, 0. So that's where we're coming up with those two. And I need to come up with I already came up with my asymptotes. You can draw them in using the fact that they are going through the origin and their slopes are, what did we say? One is positive 12 over 5, one is negative 12 over 5. The other way that you could do this to draw your asymptotes, and it fills it in very nicely, is if you use your A and your B. Remember, your B in this one is how much you're going up and down along the y-axis. Well, your B was 12 for the y-axis, for your y's. So you go up to 12 and down to 12. Again, I'm using units of 2, that's why this is working out. And we had an A of, for the x's, an A of 5. So we'd go left and right 5, which is here. So, and we'd go ahead and draw our box. So we'd go to 5 and go draw our box, our sides at 5 of our box. And we draw our top and our bottom of our box at positive 12 and negative 12 from our B. So we have our box there. And then, based on that, our asymptotes would go through the origin here at 0, 0. And we'd cross through the corners of the box, just going like a diagonal through the box on both directions. And that would make up our asymptotes. And then to draw our actual graph, we'd say, well, we know where our vertices are, and you would plan on starting at the vertices and heading out towards your asymptotes on either end. Again, starting at your vertices and heading out towards your asymptotes on either end. It's not perfect, but that's a good idea of what your graph would look like. So let's look at our graph and let's talk about its domain. Okay, its domain means that we're going to look at reading its x values from left to right and asking where is there a graph. Well, from left to right, notice that we have a graph that extends forever on the left, but it stops here at that first vertice or vertex. So where does that actually start or stop here? Is at negative 5. And then on the other side, it's going to pick up at the other vertex at positive 5, and we'll continue on forever towards positive infinity. So we have our negative infinity to that first vertex, and then we have the second vertex towards positive infinity. That's our domain. However, because our graphs shoot out left and right, they actually go up and down forever. So if you were actually looking at the range and how far up and down they go up and down forever, which is why the range is negative infinity to infinity. Let's look